This is a small initiative to explain the steering geometry, that is nothing but wheel alignment angles. So these are the parameters which defines the wheel alignment angles. The suspension height, camber, steering axis inclination, scrub radius, included angle, caster, toe, turning radius, setback and the thrust. Out of this, the camber, caster and the toe, these three parameters is adjusted at the time of your wheel alignment. So next thing is suspension height. It is a distance measured from some specific point on the body, frame or a suspension to the ground. Here in this figure, the A is your suspension height. It becomes incorrect because of the bending of your suspension part, sagging of your spring, failure of air suspension system if it is provided. This suspension height directly indirectly affects your steering geometry. So that's why the suspension height is an important parameter. So next thing is camber. The camber is inward and outward tilt of a wheel when from a vertical when we viewed the wheel from a front end of a vehicle. The outward tilt is a positive camber, the inward tilt is a negative camber. Here in this figure it is shown. So why we provide the camber? The camber is to explain that one. Uh, it has been explained in this figure. So why we provide the camber? If you don't provide the camber and the vehicle is unloaded conditions, so the whole width of a tire will be in a contact with the road surface with the straight up and down position of a wheel. But whenever we load the tire, whenever we load the vehicle, the wheel will get tilt inward, and as a result of which only inner side of the tire will in a contact with the road surface, and because of that the inner side of a tire will get wear out faster. So uh, so to avoid this thing, this is not a good sign. So to avoid this thing, we provide the positive camber. So with the positive camber, whenever we load the vehicle, the wheel will get tilt straight up and down position, and as a result of which the whole width of a tire will in a contact with the road surface. So this is why we provide the camber. The next thing is, this is a specific condition when the suspension arm will have the same length. So whenever the vehicle with both the arm will have the same length and the wheel hit the bumps, the camber will become a negative camber, and whenever the wheel goes in a hole, it becomes a positive camber. So this is one of the specific conditions. So next thing is, whenever the vehicle move along the crown profile of a road, because most of the road have the crown profile. So because of the crown profile, the driver side of the wheel is at a higher position than that of the other, that is the conductor side of the wheel. So because of this one, the axle of a vehicle will get rotate like this, and as a result of which the conductor side of the wheel will have the negative camber. So to avoid these things, we provide slightly higher camber to higher positive camber to the conductor side of the wheel. So this is also one of the behavior. Next thing is whenever the camber behavior along the turn. Whenever vehicle takes a turn, the body forces and the centrifugal forces act on the vehicle. The body forces get transferred from inner side to the outer side of the vehicle, and the centrifugal force act at the bottom of the wheel, and as a result of both of which the negative camber happens at the outer side of the wheel, and the positive camber occurs at the inner side of the wheel. And to avoid this is also behavior of a camber while taking a turn. So next thing is with the uneven camber. If you provide the uneven camber, what happens? With the uneven camber, the vehicle get pulled toward the positive side of the camber. And to explain that one, we have to consider as a wheel as a base of a cone, and the cone is resting on one of its slant side. So and whenever this will get rotated, that is the base of the cone will get rotated, it forms the ICR at the apex of the cone, and because of that the whole wheel, the base of the wheel get rotated about this ICR, and as a result of which, whenever we provide the uneven camber to the vehicle, the vehicle get pulled toward the positive side of a camber, and this is how camber behaves. But if the camber get incorrect, what happens? The side pulling will happen, then unstable steering occurs, wandering happens, and hard steering occurs. So these are the this is the behavior of a camber, and uh, how it affects the steering geometry as it becomes incorrect. So this is all about the camber. We'll stop here.